Okay, welcome back. Think about why do you need a network? And a computer network to be more precise. Well, if you had one computer that can do everything for you, you're set. Unfortunately, that is not reality. So to expand your computing capabilities, you typically connect through your Wi-Fi or through your LAN physically to some sort of a router at home or at work, where from there you have a gateway to the world and you have access to websites, services, etc., including signing up for this course. So it is an important aspect of our life now. We used to go to the market, we still do, but not now. We probably spend more time purchasing stuff online than going to a store. And that is the reality that we're living in. So, we need to understand, how do we access a service from, let's say, a local computer or from your phone? So let's simulate that scenario with a computer connecting to a server. So notice here I clicked on the group computers. I'm just going to pull out a computer or a laptop or any of these devices that are available for the public. Servers are a little more expensive. We're going to leave that for the service that you want to access. So let's take a PC and put it right here. Okay. So this computer here, I can turn it on, turn it off. I can install applications in it. As long as those applications can run on this computer without needing the internet, then I'm fine. However, like I said before, most likely you're going to be wanting to download files. You may want to play games online with other people, etc. So you need to access some form of a service that will allow you to take advantage of your expanded expanded capabilities. Well, let's put a server. Let me put a server right here. So let's say we want this computer to access this server. The simplest form of communicating between these two is to put a link between them. We're going to put a physical link. So let's go over here and we're going to do a crossover. And again, we will have a lesson to explain what crossovers are. A crossover cable that connects with this fast Ethernet to this fast Ethernet. Now, this is in its simplest form. That means, is there more to it than that? Absolutely. What if I had more than one computer? What if I had more than one server? Then this architecture will not work. And the fact that you have one port, one Ethernet port on either one of these two devices, limits you in terms of connectivity. This is the only possible connection between these two devices. And at this stage, these two devices better be in the same area, in the same room. Speaking of which, they must be also in the same domain, which means they have to be on the same network as it stands. Now, most servers that you will access through the internet are going to be into different networks. Well, that's another lesson that we will tackle once we understand the hierarchy of how networks work or how they are distributed through those hierarchies. At this stage, the hierarchy is fairly simple. Okay, so it's one link, two end devices. Can they talk to each other? Not at this stage, because if I highlight any one of these computers, none of their identifications are set other than their MAC addresses. So if you look at the MAC address for the MAC is the physical address. But that's not enough for these two to start negotiating or exchange data. We need a logical address called an Internet Protocol address or IP address. And we have to make sure that when we assign that IP address, that these two devices have unique IP addresses. They cannot clash by being the same. However, they have to belong to the same network, which means in the same broadcast domain. And again, we'll have a lecture on broadcast domain and collision domain and understand the difference between them. At this stage, we want them to be in the same broadcast domain, and the mere fact that we have a link between them, they are in the same collision domain if we're using Ethernet. So let's go ahead and set up the IP address for our server. So we can go over here. And the way to do this, you click on it, and then you click on config. And notice you have fast Ethernet 0 right here. And don't mind these. We're going to be looking at these in another lab. So for now, you go straight to fast Ethernet and set up an address. For now, take my word for it. Just set the address as I give you, 192.168.10.1. Now, this is what we call a private address, class C. Now, notice that the subnet mask will be automatically generated based on the way it is subnetted. At this stage again, don't worry about those details. Just make sure you enter the IP address the same way I just did. So 192.168.10.1. Okay? So this will be the logical address for this particular computer. So let me close here. Let me highlight again. Go over it. And you can see now that it has an IP address of 192.168.10.1. The /24 next to it is the subnet mask. That's your, let me go back here. That's this 255.255.255.0. It's another representation of this mask here. And again, that will be for another lesson. Good. Now we're going to do the same thing for the PC. So that way they are both in the same network. We're going to go to fast Ethernet, and we're going to do 192.168.10.2. Notice the other one was .1. This one is .2. The last, what we call octet. In this particular configuration is for the host ID, which means we have two hosts. So let me click here. You notice they're using the same mask. So when we say host or end node, we could use them interchangeably. So we have two hosts or two end nodes. And let me highlight here. This one is .2, 192.168.10.2. And let me highlight this guy. And this one is 192.168.10.1. Okay? We will learn from the IP address and how to distill the network part of it and the host part of it. Right now, 1 and 2 identify which hosts we have. So they cannot be .1.1 or .2.2. Okay, so they have to be different. Excellent. Now, can we have these computers ping each other to make sure there is connectivity? The answer is yes. Let's click on the computer and let's go to the desktop and go to the command prompt and actually ping the other computer. Pinging means I am sending an ICMP message out to see if I'm going to get an echo back, right? So it's going to be, I'm going to get a reply that says, hey, yes, I'm right here. And so it's like hello or hello. Okay, so that's what a ping or an ICMP message. But you're going to have to enter the address of the destination where you want to reach, 168.10.1. Remember, this is .2, so we want to reach .1. So let's see if we can reach it. And notice we're getting replies. This here means we are getting replies, okay? And we will, in another lecture, break down all of these messages as to what they mean. So that means, and this is, I'm going to highlight this, I have 0 losses. Everything, 4 packets were sent, 4 were received. So everything is good in terms of the link and its health. The configuration is correct. So we're going to do the same thing from the server. We can do the same. So I'm going to go to desktop, and I'm going to go to the command prompt. I'm going to ping the other way around, which is 192.168.10.2 this time. Okay? And notice I get a similar message. Okay? And again, 0% losses, which means the link is good. Now, the fact that we have a server, I would like to use it for something. So let's click on the server again, and let's go to services. So in services, in this column right here, you've got all sorts of services you can use. What do you want this server to do? It could be a DHCP server, which dynamically assigns IPv4 addresses to devices connected on that network. Could be a DHCP version 6. It could be a TFTP server, etc. Even an email server. I'm going to do HTTP. HTTP means it's a web server. And notice it has an index page, it has an image, so it has a whole bunch of HTML files that it's hosting that we want clients to be able to reach it. As a matter of fact, we can edit the file right here, and we can see that we have an HTML file that if we have a browser, we will be able to interpret it without these tags right here and see it as a web page. Well, which web browser is going to allow us to access this? On the client side, which one? Well, the PC is going to be the client for this service. Well, let's see. So let's go over here this time. You're not going to run this from the prompt. You're going to run it from the web browser over here. So I'm going to click on web browser. And notice it's asking me for a URL. Now, typically, if you were going to enter a URL, you would do www. Whatever the name or the resolved name for that website is .com or .edu. At this stage, there is no DNS out there or a domain name server. This IP address for this server has not been mapped to any name. So the way to access it is by using the IP address. All right, well, let's do that. 192.168. And you type that as if you're typing www.google.com, right? So same thing. But you're typing the actual IP address that you want to reach, that 10.1. Now let's see what happens. And there you have it. Remember that text with the tags? This is what it had in it. Okay? And it runs just like a website. So I can go to image page. You can see here. I can back from here. I can go to this image and back from here. I can go to copyright. So as you can see, there are links to other pages from here, right? And I can forward link here. Here you go. You can see from this address /copyright.html. So as if it's another file from that point other than index, this is what you're getting. So typically when you go to this link here, which is an IP address, you're opening the index page that's stored in that directory. Okay? So the server, PT, is acting as a web server, and we're able to access it through the computer. So this is the basics of networking right here as to using the service available by that server that you have access to.